Hey y'all, I want to show you a really big fundamental in algebra, and it's evaluating expressions. Basically, it's a expression or like a math problem where there's like alphabets in it, just like randomly thrown in there. And then they tell you which each little alphabet means. They like assign like a number to it. And then you throw that number in and then you solve the problem. So sometimes there's different steps. Sometimes the steps seem a little bit tricky, sometimes it's straightforward. So I have a handful of examples. And with this, we got to remember that we have to use PIMDOS, parentheses, exponent, multiply, divide, add, subtract. So these guys right here, we got to follow those rules. You know, when you start getting like a bunch of different symbols and shapes and stuff in these problems, you got to remember PIMDOS. So let's do the first one together. So I have A, B plus C, and it says evaluate. When it says the word evaluate, it's telling you to like assess, answer, take a look at this little guy. So we already know we're solving the problem when you see that. It says evaluate A, B plus C if A equals 5, B equals 4, and C equals 3. And if you look really carefully, A, B, and C, all those numbers are positive because you're going to get like positive and negative stuff with algebra. You're going to have like integers. And integers is like basically any number. It could be plus or minus, including 0. And it goes into like a million. It goes in forever, right? It goes into infinity on both directions. So you also have to consider the um, the signage. So there's a handful of things you have to like keep track of and organized as you're going through these. So let's try to take a look. I have A, B plus C. So I have A is 5, B is 4 plus C. Right here, A and B, they're touching each other. That's understood that they're supposed to be multiplied, right? So I could do 5 times 4. I could do 5 dot 4, or I could do 5 parentheses, right? All of these are the same. They're the exact same thing. You're going to get the same outcome. They're just 3 different ways of showing it. I'm just doing like the parentheses. So let's see. What do I do next? Because I set everything up. I have multiplication stuff going on and I got plus sign stuff going on, addition. What do I do? How do I know what goes first? Well, we look at PIMDOS, right? PIMDOS is like, this is never going to leave your side, you know? It's going to be there with you forever, basically. PIMDOS is not a unicorn, you know what I mean? It's not like a weird once in a while thing that shows up in your life, like in your math life. PIMDOS is basically like the family dog. It's always there. He follows you into your house. You have to go give it walks. And every time you try to eat dinner, it's just there looking at you. PIMDOS is literally up in your life. So you got to know it real well. So let's see. I have parentheses and I have addition. So let's see. Looks like parentheses goes first, right? And then multiplication goes first too. So we totally know that we're going to do 5 times 4 first, and then we're going to mess with the 3 later. So 5 times 4 is 20 plus 3. Great. And then I just have the plus sign left. So 20 plus 3 is 23. This is the final answer. It's pretty straightforward. But the thing is, there's so many little tiny pieces of information and hacks that you have to memorize. Let's try another one. We got a bunch of them. Okay, great. So here's another one that we're evaluating. So it looks like I have a square right here, right? So this is going to look like a parabola of some type like that. So anytime there's a little number 2 dangling, we're looking at quadratic stuff. That's not really that important here. Okay, so it looks like I have 2 positive numbers. I have a 2 and a 9. So let's go ahead and the first thing you want to really do is replace all of the shapes. And if it's a little bit too much, like it feels overwhelming, go ahead and rewrite it and just leave out the alphabets. Do you see how I'm leaving them out? Now, everywhere you see an X, you replace it with a 2 because it tells us to do that right here. So where is the X? It's right here. There's no other X's. Okay, cool. So we got rid of that. What about Y? Let's see. Let me see where the Y's go. There's one right here. I could put that 9 right there. And it looks like there's no other 9s or y's or anything. So we got rid of that. So it looks like everything is filled out. So we're good to go. Okay, we follow PIMDOS again. So it looks like I'm going to do the exponent first, this little guy first. And every time we do that, it gets thrown into whatever is sitting next to it. So it's going to look like this. 2 times 4 plus 3 times 9 plus 6. Great. So next we're going to multiply everything together. 2 times 4 is 8. 9 times 3 is 27 plus 6. Now we're going to add all that together. It gives me 41. All three of these added together. 41 is my final answer. Right? So these are on kind of like groups. Parentheses, exponents go together. Multiply, divide goes together. Add, subtract goes together. I don't think I have a video on PIMDOS. Maybe I should make one. Let's do another one. So I have this one, and this time it's not X, Y, and Z. This time it's P and Q. And they're also negative. Okay, it's getting a little bit tricky now. And P and Q, in my opinion, they kind of look alike. So you've got to keep a real sharp eye when you do this. Let's try the method we were doing earlier, where we just fill everything out and leave out the alphabets. I don't have a pencil. I'm using like this digital tool. But you know what's cool is if you put in the alphabet really carefully and then just go back and erase it and then replace what you need. I think that might be a little bit more organized. Perfect. So I rewrote the problem and all the alphabets are left out. So I'm going to put a -3 in here because it told me to do that. And I'm going to put a -8 in here because it told me to do that. So I used it all up. Okay, cool. My problem is filled out. So now I can go ahead and solve it. So I don't know, maybe your instructor is cool with you using a calculator. Some of my instructors were cool with it, some of them weren't. So anytime you have a negative number, anything, it could be anything. Let's just do an X for any, well, let's do a number. Let's do 2 or a million. Let's not do a million. Let's just do that. And there's a 2 dangling at the top, that's square. It's always going to be positive. Always, no matter what. And you could try on your calculator. You can just type in any old thing you want. Make sure it's in parentheses. Some calculators, they don't know. And you put that negative in there. Every time you do that with the square, it comes out positive. When you do it with a cube, this little 3 thing, it's going to be negative. So just keep in mind that it's going to turn into a positive for this problem here. So we're going to do the exponent first. So -3 squared is actually +9. +9. It's not negative, it's positive. Plus 5 times 8 and 7. Great. So what's the next thing I do? Well, I'm going to multiply everything out. So that would give me, that's going to give me a -36 right here. Oh, that's going to give me a minus. Well, let's do that. Let's do plus, and then this is going to be -40 minus 7. Right? And then let me go ahead and clean it up so I don't have all these extra operators, the plus minus sign things. Great, so that's what I have now. Let's see, let's start from the left. -36 minus 40. Let's do this one, let's do these two. Let's do -36 minus 47 gives me -83. This is the answer. Let's do a different problem. That's a fraction, right? So this is a really good one. I want to show you. Let me rewrite it just real quick here. There's a 5 in the bottom. That's called the denominator. The operator is a plus sign. And then the denominator is B plus C. And then it gives you a bunch of alphabets, right? Right here, it tells you how to fill it out. Okay, here's what's up. Maybe you're kind of looking at this and thinking, oh, cool, just put a 5 here and then put a B plus C here, right? Just do that. And then everything in the bottom is chill. So here's the thing. With these problems, maybe you didn't know to do that, and that's cool. It's not a big deal. So what's up is when you get fractions, you got to make sure the bottom parts match. When you have a plus or minus fractions, like right here, that they're telling you to add two fractions together, you gotta make sure that the bottoms match. And one way to do it is the way I just showed you, where you put a 5 up here and then you do that B plus C thing here. But the issue is we're going to start filling out the alphabets, right? All of these are going to get filled out. So it's going to change all the bottom. We don't know what the bottom is going to look like. So as a rule of thumb, when you're evaluating expressions and you come across a bunch of fractions, go ahead and fill out A, B, and C first, and then decide if you're going to start making the denominator even out, because sometimes it ends up even. So let's try it here. We're not going to do the 5 and 5 and B plus C thing here. We're not going to do that. Let's just try it without that right now, just so we can see what's up. So I have A plus C over 5, which is 3 plus 7 over 5 plus I have, where is it? Is that an A? I have 3 over -2 plus 7, right? Well, what does that give me? Well, it gives me a 10 over 5. Resist the urge to reduce. I know we're seeing this and maybe we can make it smaller. Just hold off on all that with these kinds of things. Because no matter what, it's always going to come out really good and clean at the end. So if you start doing that now, if you start like simplifying now in the middle of the game instead of at the end, you're going to have to do a whole extra step to turn the fraction against a whole number into two fractions. There's no reason. We already got two fractions going, so keep it as it is. So the second term, the second part, is 3, and then -2 plus 5 is actually 5, right? So do you see how this whole thing right here became this whole thing? Okay, so what's up is the denominators are the same, right? The bottom parts match. Remember the boot and hat method we were talking about? I have a video where it shows you how to add and subtract fractions, and I call it the boot and hat method. Basically, your shoes have to look exactly alike. Your hat could be anything, it doesn't matter, but your boots got to be the same. Well, it turns out, as we were just applying all the alphabets in there, it totally helped us out. It made it even. I never had to do the 5 and the B plus C thing. I never had to do that, because then I would have to like distribute and it would have been all these crazy steps. It totally organized it for me, so we're chill on that. So let's go ahead and keep finishing it. So I have 10 plus 3, it gives me 13. And then the bottom part, they're both the same, so it stays 5. This is my final answer, although this is an improper fraction, right? So what does that mean? It means the top number is big. That's all it means, right? It's just a fancy word for the top is big. I call it improper fraction club, which means you have a big head and small feet. So that's how you join the improper fraction club. 13's bigger than 5. He's in the club. What's up is you can make it into a mixed number. And how do we do that? Long division. Because sometimes they're going to tell you to do it a mixed number style. You're not allowed to have it improper. I've had classes where you are absolutely forbidden from having improper fractions as a final answer. Like they will take so many points off. They're not chill about it. So how to do improper fraction is you take the bottom number and you stick it on the outside, right? So it's called the denominator. D for denominator. Doggy's on the outside of the house. This is the house, right? Numerator lives inside. Doggy lives outside. So that's a good way of remembering it. How many times does 5 go into 13? It goes in twice. What is 2 times 5? 10. Remainder, 3. So you take the top number, and then you put the remainder next to it, and then the denominator is the same. Did you notice they're both 5 right here? Denominator is always going to be the same for mixed numbers and improper fractions. This is also the answer. So this is cool, and this is cool. This one is called mixed number. fraction. Let's call it that. So one's improper, one's mixed number. Both are chill, both are the correct answer. It just depends on what your instructor is cool with. Let's do another problem. Okay, sweet. This is a good one because we got a negative here, we got a positive here, and look, we got a cube, and then we got a square. So we got a little 3 and we got a little 2. How exciting. Okay, let's do this one. So I have 5, and we're going to do that big gap with the 3. We got to make sure we put that 3 in. This is a product. These are being multiplied. It's kind of hard to tell. So let's do a little dot to show that it's going to get multiplied. We're going to do a blank space for y. I love Taylor Swift. Okay, let's see. And then what goes in there? We're going to do a -2. And then y is a 3. Sweet. Okay. Great. And what do I do next? I am going to do the little exponent guys, little nth degrees. And it goes right into that. So what does that look like? What does that give me? Well, I have 5 here. So -2 times -2 times -2 is actually 8. But it's a -8. So you do -2 times -2. What does that give me? It gives me +4. It gives me positive because 2 negatives make a positive. Then I have to do one more. I have to do it one more time. So I have that +4 times -2. Well, it gives me 8, but there's a negative, right? That's how I got that. Times 9. 3 times 3 is 9. Same thing. 9. Great. So what do I do next? Let's see. Let's do the 5. Let's distribute the 5 in there. So -8 times 5 is actually -40 times 9. What does that give me? It gives me negative. You got to make sure that negative is there. I'm bringing it down. 360. Great. That is the final answer. Let's do some more. Okay. This is a pretty good one too. This one's pretty nice because you know what? There's 2 x's. And that's it. There's just one thing to plug in. So let's try that. And in case you're wondering what shape this is, it's a quadratic. Why? Because it's that little 2 dangling. It's going to look something like this somewhere. Right? So let's see. Let me get rid of that just in case we need that space. So let's go ahead and fill out the template with our blank space. Okay, I'm going to put a 3 in everywhere. That was pretty easy. I didn't even have to think that hard about it. So let's do 9 plus 4 times 3 minus 7. What do I do next? Well, we're going to multiply next. So that 4 times 3 gives me 12 minus 7. And then we're going to go left to right. These two together is 21 minus 7, which gives me 14. That is my final answer. These are pretty easy. The thing is, there's always little secret steps. Don't forget this. That's a secret step I followed. And then the other one was I had to put a 3 into everything that had an x. And I also had to remember that 3 times 3 is 9, which is the same as 3 squared. So I had to remember these 3 pieces of data in order for me to solve this. Right? So that's like the weird thing with math. Sometimes it makes you do these little tricky things, but you guys totally know these. This is not like something super crazy, right? So, and maybe you get to use a calculator, so it's like extra easy. Okay, great. So we have the same idea. We just have one little guy. Let's try this. I'm going to do a little blank space plus 8. And I'm going to put that 5 in there. Cool. Let's go ahead and determine which one goes first. I'm going to do the exponent thing. That's 25. 5 times 5 gives me 25, right? 5, 10, 15, 20, 25. Don't be scared to use your fingers or to count like this, guys. You know, there was like a paper that came out that said counting on your fingers actually is helpful. It helps you with math. And other countries count on their fingers all the time. For some reason, people in the States, it's frowned upon. When I went to school, it was really frowned upon. So, and I live in Texas. I live in the US, in the States. So don't be shy about using your fingers, right? I use a tally mark system right here. Cool, sweet. So let's see, what's next? Let's go left to right. Let's go over here. I'm going to have 20, right? 25 minus 5. The last line, you can just go right to left if you wanted. Plus 8 gives me 28. This is my final answer, right? All I had to know is PIMDOS. I had to know that, let's see, 5 square is the same as 5 times 5, which gave me 25. And I had to know, I think that's everything. Did I have to know anything else? Oh yeah, I guess I had to know that you have to put that 5 into that. That's it. That's all I needed to know to answer this. Super exciting. We're getting this. Hooray. Let's try this one. This is a good one because I have bad eyesight. And these S's, I swear, I do not know. I can't tell. You know how many times in my lifetime I thought those S's were a 5, and then I'll just do elaborate math for like 30, 40 minutes, one problem. And it turns out I did it wrong, and I got to start all over again. So this is why I like this problem, because there is an S in here. That is an S, that is an S. Those are not 5s. It's just I had bad vision. So let's try this. And what's interesting is the square's at the end, so we gotta remember to put that in there. Let's do our little gaps, our blank spaces, so we can have a little organized system going here. And let's see. The first one is an S. What's my S? It's a 3. So I got rid of that. There's no more S's. Well, what's the next alphabet? It's a T, which requires I put an 8 in there. And I'm done with that one. So I filled everything out, which is pretty cool. Now I can go ahead and start filling things out. PIMDOS. So the thing is, we got to do parentheses first, but the thing is, we can't just do everything simultaneously. We got to take it one at a time. I can't do 8 squared at the exact same time I do 7 times 3. So let's do the exponent first. So I'm just going to keep the 7 times 3 here for organization's sake. I'm putting that 2 into that, and we're doing 8 times 8, or 8 squared, right there, which gives me 64. The same thing, right? So let's do 64. Right? So we did that. Now we're going to multiply. 7 times 3 is 21. 2 times 64, it's like 128, I think. That's 8. That gives me 12. 128. Right? Okay, perfect. So we did the multiply thing. Let's see, what does that give me? That gives me negative 107. Bam. Right there. Great. This negative 107, I just typed it into my calculator a second ago. So I'm not like a math genius. I did use a calculator for this one, this part right here. Here's a really good one. There's 2 negatives right here, right? So, and the N's and the M's look a little bit similar. So we got to keep everything organized. Let's do our gaps that we said we do, or our blank spaces. I don't know what you want to call it. Let's do a 25. Cool, I got it all filled out. So I got to put my -6 where the M is, and then the N, I have to put in -3. That's a negative right there. You could barely see it. Cool, perfect. So here, let's do a nicer writing of PIMDOS, and we'll walk through it. Wait, that's PIMDOS. Okay, here's our puppy PIMDOS. He's not a unicorn, he's a puppy. He's in our bedroom. He's following us into the living room. You go outside, he's out there too. He's just always hanging out, always eager. So what do we do first? We can't do everything simultaneously, so we gotta do the parentheses, exponent stuff first. There's not really anything to multiply right now because I have to do the exponents. We could do this one first. We could. Let's try that. Let's go ahead and do that first, just for organization's sake. So -3 times 5, let's just call it 5 instead of negative 5, is negative 15, 25. And let's rewrite it so we don't have all those like little like symbols. Two negatives make a positive. Right? So we got rid of p. Let's see what's next. Let's do exponent next. So where's my exponent? What is it? Negative 6? So it's negative 6 times 2, or 6 times 6. So here's what's up. As we mentioned earlier, if you have a negative, right, with that square, it's going to be a positive number. Just like this, if you had two negatives, negative times a negative actually gives us a positive. And what does it give us? It gives us a 36. So we're going to do 10 positive 36 plus 15 minus 25. That's E. Well, I got that multiplication thing going on again, so I got to put those together. So that gives me 360, 10 times 36, plus 15 minus 25. I already did the parentheses. We're doing multiplication. We just did that with the 360. Okay, cool. Let's go left to right. So 360, and are we doing addition? Is that add? Yeah, 360 is 375 minus 25. I just did the addition. And now we're doing subtraction, which gives me 350, right? Think of it like as money. If you had, well, I don't know if that's even useful. If you take away a quarter, I don't know, 350. I don't know. Some people are good with quarters. So like 4 quarters make $1. Okay, sweet. So this is my total. This is my final answer. And we went through all the PIMDOS stuff, right? We, I guess, cut our puppy apart. I don't know. That's what we did. What can I say? Okay, so here's the next thing. We have, oh, great. Here's a great example. You're going to like this one. We mentioned earlier, don't immediately start like, what is this? Is that a plus sign? Okay. So do you see how I have this y in the bottom? So maybe you're thinking, okay, cool, let me just even it out real quick. I'll just go ahead and do that. Okay, but we don't know. We don't know what this y is going to look like. So let's just hold off on that for a second. So we got to take it one step at a time, right? So let's take a look. So what is my x? Oh, let's go ahead and fill everything out like we used to before we jump the gun here. Jump the pew. Okay. So we have a 1 here, and then we got a 1 here, and I don't see any more 1s, so we're done with that. And then every time there's a y, I got to replace it with a 4. That's done also. Cool, sweet. So what does that leave me with? What does that leave me with? I have half 1 over 2 plus 5 over 4. Right? And now at this point, I'm going to take a look and say to myself, are the shoes the same? Right? With the boots and hat method, every time you're adding or subtracting fractions, we got to apply the boot and hat method, which means, are my boots the same? They're not. My boots are not the same. I have a 4 and a 2, so I've got to figure out how to make that 2 into a 4. Well, I can multiply 2 times 2 to make it a 4, but whatever I do upstairs, I gotta do, whatever I do downstairs, I gotta do upstairs, right? Let's move that back over here. So what does that give me? Let's move it downstairs over here. 2 times 1 is 2. 2 times 2 is 4. And don't reduce right now because it's going to get tricky, you know? Save all that reduction stuff towards the very, very, very end. And then we have 5 over 4. Great. Right, that one's right here. I just pulled it down. So now if I look, my shoes are the same. So I'm chill. I'm good to go. I can go ahead and finish this problem up. I don't have to do anything else. So 2 plus 5 is 7. And then the shoes, they're just 4. Right? So this is the final answer. However, if you look very closely, it's improper fraction. How is it a part of the improper fraction club? It has a big head and tiny feet, right? So every time you see big head, tiny feet, you gotta do a mixed number. Mixed number, right? And how do I do that? Long division. Doggy goes outside, right? 7 lives in the house. The numerator lives inside the house. How many times does 4 go into 7? Just once. What's 1 times 4? 4. Okay, well, what's the remainder? 3. That's the remainder. And how do I set it up? That's the answer for the whole number. Then it's the remainder, and then it is the denominator. The denominator for the mixed number and the denominator, which is the bottom thing, for the improper fraction is always the same. So this is the final answer, and this is also the final answer. Cool. I think I have one more example, and then we're good. So this is a really nice one, right? It has a bunch of different stuff going on. And look, man, there's 3. So, and then there's also a plus and minus. So this is like a super, like, boss level, I guess. Okay, let's go ahead and do our little template outline thing. That way we kind of know what we're doing, right? Doing this little system, this like blank space thing, it reduces the opportunity for you to accidentally like type in something that you didn't want. So, and we just go through the whole thing. Let's just go through this. And look, I hit a X. So what is the first thing I see is an X. I put a 2 there. There's no more X's. Then the next thing is a Y. The Y requires I put a 3 anywhere I see a Y. Then the last one is Z, which is actually a -1. Okay, cool. So this one is tricky because it's all jumbled up together. And this is all multiplication. I don't know if I could put those dots there. Okay, everything's being multiplied. What do? I do the exponents first. 2 times square root of 2 is 4. 3 times 3 times 3, right? It's 27, 27, yeah. So that's 9 times 3, right? That's the answer. And then I got to multiply it again. That gives me 27. -1. Great. What does that give me? Well, 4 times 3 is 12, right? Times 27 times -1. Well, 12 times 27, that's 324, which I put into my calculator, times -1. Well, what does that give me? It gives me -324. Because 324 times a -1 gives me that negative part right here. So this is my final answer, right? So with these problems, all you have to remember is PIMDOS, okay? That's our puppy dog. He lives with us. It's not a unicorn. It's not like a rare thing you just kind of see or you kind of heard like lores about. This is a full-blown dog that lives with you, right? So you got to take care of it. You got to know it. You got to know when to hang out with it, when not to hang out with it, right? So he's a part of our lives. He's not going to go away. It's our puppy dog. So we have to know that, and then we have to know which alphabet is what number and then how to throw it in there, right? These are really the main things you need with evaluating expressions. And it's a big deal that you know this stuff because in algebra and calculus and trig and stuff, you're going to do a bunch of this fill in the blank stuff. So I hope this video helped. I do have stickers on my sticker shop if you want to go look at my stickers. Okay, thank you everybody. Bye.